So we proceed with what we discussed in our last class. So I will still do some more other questions. I will still be able to do some more other questions in relation to that element of the portfolio theory. So our next question I want us to check should be May 2016. The next question I want us to check should be May 2016, question number 2, part A. May 2016, question number 2, part A. So we check the question for May. (2016), question number 2, part A. So that question 2, part A. Question number 2, part A for May 2016. So it reads that Biashara Limited wishes to invest in stock M and N. They wish to invest in stock M and N in two different industries. The following information relates to the two stocks, stock M and stock N, stock M and stock N. So expected returns, they have given the figures. Standard deviation is given. Beta coefficient is also given. Amount of money invested has also been given. So now required, Roman letter 1, expected portfolio return. Roman letter 2, explain the effect on the portfolio. Explain the effect on the portfolio risk if the returns of the stock M and N were perfectly positively correlated. They were perfectly positively correlated. So this time round, expected returns have already been calculated for each. So we simply combine them together now to form the portfolio. We simply combine them together in order to form the portfolio. So we can start off with Roman letter 1, how to calculate expected return of the portfolio. How to calculate expected return of the portfolio. So expected return of the portfolio, as per what we discussed in the previous class, it will simply be the weight of M multiplied by expected return for M. Weight for N multiplied by expected return for N multiplied by the expected return for N. So the weight, you see the amount invested, M is 1.2 million, N it is 800. So when you add 1.2 plus 800, it is going to be 2 million. So the weight for M, it is 1.2 divided by the 2 millions. So expected return for M was given to you. Are you able to see 18%? This time it was given. The other question we calculated. The weight for N, it is 0.8 millions. 0.8 millions, also divided by 2 millions, multiplied by the expected return for N. So expected return for N, they were able to give you 16. So the question should be May 2016, question number 2, part A. May 2016, question 2, part A. So it should give you around it here. 17.2. So that should be the expected return of the portfolio. That is now meant to give you the expected return of the portfolio. So after that, we now go to Roman letter 2. We now go to Roman letter 2. So when it comes to Roman letter 2, yeah.
So yesterday we did not divide with one.
Sorry?
Yesterday we did not divide.
Now, Sasa, what you get the proportion, like now, 1.2 divided by 2 is the same as what? 0.2. 1.2 divided by 2 means. Yeah, so yesterday we were given in the form of percentages. Yeah. So this is the same as 0.6 multiplied by 18 plus. You didn't confirm on that. Yeah, so now let's now add up to 1. So yesterday, they gave me the question we did yesterday, you are given the percentages. But this one, they have given you the amount invested. This one, they have given the amount invested. So that is now in relation to that question, the Roman letter 1. That is now for the Roman letter 1. How to compute the expected return. So those who have just joined in, we are doing the question for May 2016, question number 2, part A. May 2016, question number 2, part A. So this one is Roman letter 1. If you compare this question, the one we did yesterday, expected returns were not given, we calculated. The proportions were not given, so the percentages were given. But this one, the proportions have not been given, but we apply the amount invested. So after that, now we go to Roman letter 2. Roman letter 2, they wanted you to calculate, explain the effect on the portfolio risk. Explain the effect on the portfolio risk. If the returns of stock M and N were perfectly positively correlated, Also, you include suitable computation. Also use the suitable computation. So to explain that particular effect, you are supposed to calculate the percentage of risk minimization. So in the previous question, we saw how to get the percentage of the risk minimization. So we need to come up with how to compute the percentage of the risk minimization. So to compute the percentage of the risk minimization, so to calculate percentage of the risk diversification, it is supposed to be given by the weighted standard deviation of the portfolio minus the actual standard deviation for the portfolio. We also divide by the weighted standard deviation for the portfolio. Then we express it as a percentage. So to compute the percentage of the risk minimization,
In the example, I was like, is it the big maths? Sec 4. Ako sawa. Beh, oniache.
So for us to compute the percentage of the risk minimization, we come up with the weighted standard deviation, and also we should be able to calculate the actual standard deviation. So for us to compute the weighted, we need to know about the correlation coefficient. So in this question, the correlation coefficient was given. The correlation coefficient was given. You have the first paper. But you can access it in the class. Oh, okay. So when you check, they were able to give you in the Roman letter 2, explain the effect on the portfolio risk. Explain the effect on the portfolio risk if the returns of stock M and N, were perfectly positively correlated. So perfectly positively correlated, you remember in our notes, that means the correlation coefficient is +1. When it is perfectly positively correlated, it means that the correlation coefficient between M and N, it is +1. If you check in our notes, when you are able to comment about the meaning of +1, it means that the two securities are perfectly positively correlated. So when they say it is perfectly positively correlated, it means it is +1. So you want to get the weighted standard deviation of the portfolio. So to compute the weighted standard deviation for the portfolio, you simply take the weight of M, the standard deviation for M. you also add the weight of n, then standard deviation for n in that manner. So for you to compute the weighted standard deviation of the portfolio, when the correlation coefficient is positive, we add. Remember I said, if it is negative, we subtract. But this one is positive. So from the Roman letter 1, we have seen the weight. The weight for M, remember you take 1.2 million divided by 2 million. 1.2 million divided by 2 million. That should be able to give you 0.6. Remember it was 0.6? When you take 1.2 divided by 2 million, and then that standard deviation for M is given as 8. The standard deviation for M is given as 8. Then also, to get the weight for N, you take the 0.8 divided by 1.2, sorry, divided by 2 million. Remember, it was 0.4. It was meant to be 0.4. So when we multiply, the standard deviation has been given as 6. So you add them together. They will be able to give you the weighted standard deviation for the portfolio. Okay. 7.2. So that is now how to get the weighted. So it is determined by this correlation coefficient. If it is positive, we add. But if you get a negative, we subtract. When we get a negative, we subtract. So that is now what we should be able to have for that question. So after that, we should now also calculate the actual standard deviation for the portfolio. The actual standard deviation of the portfolio. The actual standard deviation for the portfolio. So to calculate actual standard deviation for the portfolio, to calculate the actual standard deviation for the portfolio, you simply take the weight of M squared, the variance of M, like that. You also add the weight of N squared, also the variance of N, then also 2 multiplied by the weight of M, multiplied by the weight of N, also multiply the covariance between M and N. Then you get the square root of that information. So when you want to calculate the actual standard deviation for the portfolio for this question, to get the actual standard deviation for this question, you start with the weight of M squared, the variance of M, the weight of N squared, the variance for N. Then you also add 2 multiplied by the weight for M, multiplied by the weight for N, also multiplied by the covariance between M and N. Then that covariance was not given. We need to calculate the covariance. So to compute the covariance, remember correlation coefficient. Correlation coefficient between M and N is supposed to be given by covariance between M and N divided by the standard deviation for M multiplied by the standard deviation for N. So we make these covariance to be the subject because the other three are given. Making the covariance to be the subject, making the covariance between the subject, you simply take correlation coefficient between M and N multiplied by the standard deviation for M multiplied by the standard deviation for N. So to get the covariance between M and N, you get the correlation coefficient between M and N multiplied by the standard deviation for M multiplied by the standard deviation for N. So correlation coefficient was given in the form of the what? Remember, perfectly positively correlated. Perfectly positively correlated means it's +1. So this figure correlation coefficient is +1. That +1, you get it from the Roman letter 2. They said that they were perfectly positively correlated. When perfectly positively correlated, it means the correlation coefficient is +1. The standard deviation for M, it is given. Are you able to see 8 multiplied by 8? The standard deviation for N is also given. Are you able to see 6? So that one should give you 40 watts. So you get a figure of 48. You get the value of 48. So now after that, we should be able to come back to our equation to get the action. So the weight for M, you have seen the 0.6? Yeah, so we take the 0.6 squared. This is the variance for M. To get the variance for M, you square the standard deviation. Our standard deviation is 8. So you take 8, you square N. That weight for N, it was 0.4. The 0.8 million divided by 2 million should give you 0.4. You square that. Then we also square the standard deviation, which is 6 like that. Then now 2 multiplied by 0.6. Online, we are getting which figure? I've seen 7.2. Yeah, we are getting 7.2. So now once you have done that, we go back to compute what is supposed to be percentage of the risk minimization. We can now come up to compute the percentage come up with the percentage of the risk. So weighted, we got 7.2. Actual, we have also gotten 7.2. Also divide again by 7.2. So when you express it as a percentage, you get a 0. When you express it as a percentage, you will be able to get it as a 0. So now we can explain the effect. You see, we get a 0. So we can now make a conclusion. Therefore, if M and N, are combined to form the portfolio. Therefore, if M and N are combined to form the portfolio, if M and N are combined to form a portfolio, then there will be no risk minimization. If M and N are combined to form the portfolio, then there will be no risk minimization. There will be no risk minimization or diversification. There will be no risk minimization or diversification. So that should be the information about that question. So another question I would also like us to go through. The other question I also want us to go through. I want you to check November 2018. November 2018. Question number 1, part C. November 2018, question number 1, part C. November 2018, question number 1, part C. November 2018, question number 1, part C. November 2018. Question number 1, part C. So that question 1, part C for November 2018, it reads that the following data relate to the probability distribution and the returns of security A and B, of the returns of security A and B. They gave you probability, also security returns for security A and also security B. For security A and also security B. So required the proportion of each security to be invested in the portfolio in order to attain a 0 portfolio risk. In order to attain a 0 portfolio risk. So for that question, they have not given you the proportions. They would like you to calculate the proportions. So to get those proportions, because it is between security A and B. So we use that actual standard deviation of the portfolio. We use that actual standard deviation of the portfolio. We use the actual standard deviation for the portfolio. Remember to calculate the actual standard deviation for the portfolio. Remember, for this question, it is A and B. So we take the weight of A squared, the variance of A. We add weight of B squared, the variance of B. Then, remember, we also add to the weight of A, the weight of B. Then, covariance between A and B, like that. Then, get the square root, like that. Come up with the square root. So, they want you to calculate the weight for A and the weight for B. So there are two unknowns. We shall have one unknown. Then they have said that in order to attain zero portfolio risk, so that means this figure is zero. You see in the question, in order to attain zero portfolio risk, that will mean that this figure is at zero. Then the weight for A. So we have two unknown, the weight for A and the weight for B. So you remember in the previous question, when you add the two, must add up to 1. Remember 0.6 and 0.4. So instead of having two unknown, for this part, we say it is 1 minus the weight of A squared. Yeah. Instead of the weight for B, we replace it with 1 minus the weight of A. I want to remove the weight for B, so we only have one unknown. The same thing will happen at this point. Even this one, you replace it with 1 minus the weight of A, because the two must add up to what? 1. The two should be able to add up to 1. So I don't want to go into much details on getting the weight for A and the weight for B. What we should do is simply, we make the weight of A to be the subject. I'm already simplifying the formula. So it will be given by the variance of B. We subtract the covariance between A and B. Then we also divide by the weight, the variance of A. You also add the variance of B. Then you minus 2 covariance between A and B. So if you go to that formula and you simplify it, making the weight for A to be the subject, you will end up coming up with this formula. So I don't want us to go into detail on how to formulate that, but that is finally what you are going to have at that point. That's now finally what will be. To get the weight for A, you will come up with that kind of the formula. So to get the weight for A, simply get the variance for B, then you subtract the covariance between A and B. Then you also divide by variance for A plus the variance for B minus 2 covariance of A and B. So that is how finally it will turn out to be. So that should be now the formula you will be using, just in case they would like you to get the weight. So that now requires you to calculate the variance for A, the variance for B, and also the covariance between A and B, and also the covariance between A and B. So you start off with calculating. You start off with calculating expected return for M Also expected return for B in order to enable you to calculate what is supposed to be the variances for the two. So we start by computing expected return for A. So to compute expected return for A, you simply take each return. The first one is -5 multiplied by 0.1. The next one is 10 multiplied by 0.25. The next one is supposed to be 15 multiplied by 0.4. 0.4. Then finally 20 multiplied by 0.25. Then you will also compute expected return on B. So compute those figures. Then once you have calculated them, we can have a short break for those who are going for the prayers. We can have a short break for those who are going for the prayers. Then when we come back, we shall continue with the question.
Inaweza kuwa kwani tumekaa how tumekaa 4 weeks. Yeah, classmate. Na wewe ndaka at least sijaiona na 4 weeks, naona na 5 weeks.
Mpaka next week.
Mimi ndio nasema ninapenda. Ndio. Hata ukapo ujapata nini? You know why you have to continue doing that? 3 months kidogo sana za kusema tutaingia. So hata ukaona receipt, unajua utakuwa umeshasoma hiyo. So hiyo utaisomea ukiwa nini unajua kuna hiyo.
Ilikuwa shati.
Kwa nini jaingia? Si nimembe. Nafaa kuingia automatic. Nilikuanga huko. Oh, that you can not be available. Pia sije pia wagomea. Sio kitu pia wametoka kulipa hii.
Huh? Kwa nini? Angeulizia baba, sasa hizi ulizia. Unajua zinakaa pamoja. Sasa yeye kelele yake kubwa ni kama hii panda gari hapo. Naona anatoka. Yeye hataki kuuliza. Sawa. Sawa. No. Acha nifunge. Sina no.
Basi unaweza kufuatia Lakini sasa nimesikia lazima mtu atakusia exam sita kwa kifanya wako resource. So nikiongea nao mwalimu wa tax ndio nitajua kama nitamwingiza. That's what I think. Simple tax is never that's the only thing.
Na sisi tunafanya kama mimi tunafanya lakini ile wani ya okay, sawa. Sio ni exam. Na tunataka anafanya exam.
I have no idea what's going on. Public finance. Ama ni mimi nimeendelea sasa kwa sana. Nimeendelea mpaka nashukuru kwa mbele. Sema hivi vitu. See,
but my handwriting
me hapo is worse.
So what are we coming up with as the expected return for XA? Exactly 13. This one is 13. Hii ingine ni ngapi? Online, I'm told is 8.75. I hope that is the case. So now after that, we should come up with the covariance. Covariance between A and B. So to get the covariance between A and B, when you are using the formula, the other question, it was the reverse. The correlation coefficient was given, but this one has not been given. So you follow that approach. So you compute that way to get the covariance between A and B. So we are getting which figure? Sorry? Online, you give me your value. what are you coming up with? So what have you calculated? No one has computed. What a negative 20 was? It's not correct. Online, someone has given me negative 21.25. Almost everyone online are giving me negative 21.25. That's the correct figure. So once you have calculated that, you also need now to compute the variance for A and also the variance for B. You also need to get the variance for A and also the variance for B. So variance for A, you get the summation from the first to the last. So you get the return for A minus expected return for A. The difference you square multiplied by the probability. The difference you square multiplied by the probability. So we shall not get the square root because we are looking for the variance, not the standard deviation. So the first one for A is -5. You also subtract 13. So that should give you the variance for A. So you are not getting the square root, but we just compute it in that order. We now also compute the variance of B. So once we have finished those figures, we can now get the weight for A. We should now come up with the weight for A. So using the formula I had given you to compute the weight for A, from the formula that you have up there, you start with the variance of B. We start off with the variance of B. So from what you have just calculated, that variance of B, you are getting 29 point what? The variance for B is 29 point. 29.68. Like that. Yeah. Then we subtract the covariance, which was negative. And we had already calculated that figure, it was negative 21.25. So minus negative 21.25. Then we also divide by, we start the variance for A. The variance for A, you got 40 what? You got 48.5. So now, so you can round the final figure into 2 decimal places. So the final value, you can round it off into 2 decimal places. So it is 0.4. And no one was computed. We are getting 0. What? Someone to give me the figure. If you round it off to 2 decimal places, 0 point. So you get 0.42. 0.42. Yeah, you get 0.42. Then, so that's now the weight for A. The weight for B, it will be 1 minus 0.42, because the 2 must add up to 1. So when you want to get the weight for B, you simply take 1 minus 0.42. Yeah, so that is now how you are meant to get the weight, the proportions. So there is a similar question of that type in the sitting of August 2022. There is a question of that similar nature in the sitting of August 2022, question number 1, part B. August 2022, there is a question number 1, part B. There is a similar question in the sitting of August 2022, question number 1, part B. Question 1, part B. So that question, I'm not doing it now. You can just go through it. When we meet in our next class, I will be able to do that question. When we meet in the next class, that is now when I will be able to do that question for the sake of those who have not reported. So I want us to stop there for today. I want us to stop there so that when we meet now in the next class, I will do that particular question. So that question, you remind me, it is in the sitting of August 2022, question number 1, part B. Question 1, part B. So when we meet, we shall go through that question, or if you have enough time, you can also go through the question and see what you'll be able to get out of it. You simply follow the same procedure I've done, then it will be able to work perfectly for you at that point. So let us stop there for today. Let us stop there for today, so that when we meet now in the next class, we shall be able to do that particular question.